Hey, I'm Paul Sinenko, and today we're going to talk about charts. Charts seem to be a simple component. They certainly start out simple, but they can get pretty confusing very quickly once you start digging really deep trying to do some heavy customization. So in this episode, we're going to go over various charts, how to configure them, how to deal with dynamic series, which is basically the common point of frustration for many users, and we'll look at other cool ways to use components outside of the chart to work with the chart to get the results you're looking for. So let's go ahead and get to the controls and start digging into charts.
Hey, welcome to the controls, and well, let's start with obtaining a chart. How do you add a chart to your page? There are two ways to do this. You will typically find somewhat pre-configured charts under Dashboard Library. What you find below, it's included with the default project template, and here under Charts, you'll find several charts already pre-configured for you with some colors and some basic settings that would make it a little bit faster to just link the data and go. They even come with sample data in the form of a table that's located on the data flow of each respective chart, and it's already pre-bound to the series. So it has two series, and then if we expand the data portion, there's a data source, right? That's that same table, of course, with the X and Y fields that get plotted. We'll get into properties a little bit later. So that's one way to grab a pre-configured chart and just tweak it for your needs. If you truly want to start from scratch, you'll find the basic chart component under right-click Insert menu. So right-click Insert Components. Charts and chart. It looks like this, like nothing. Basically, it contains no components visually. If you expand it in the data flow, it only contains the plot area. So here you can't really add anything meaningful here. These actually are not going to add anything to your chart. The only way you can add series and axes is by dropping data onto the chart, and that is done like so. So let me open one of the data tables, and remember, chart is always driven by a data table, right? Whether it's a history chart or a life chart, there's always a data table driving it. All right, so here's a data table, and we create a series on the chart by simply grabbing the column we're trying to plot and dropping it on to the chart. So this will prompt you with a dialog to create new series. Now, if you keep this dynamic unchecked, it will only create a series for the column that you dropped. Or actually, you can reselect the column here if you really wanted to. In this case, it's X. I'm plotting X vertically as a linear axis, and of course, I need to choose what's my Y. Now, this is not a history table. It contains no timestamp. So I can keep it as linear axis and plot X against Y. Right? Or I can also make Y to be category axis. You would use this for a string. So you put labels there rather than numbers. And of course, date time. If you're dealing with a history table and you have a timestamp column, then you would select date time as an axis type, and then choose that timestamp column from the list. You can also pre-select the series type. So some of those are interchangeable later, but not everything. For example, you cannot convert basically line or area series chart to pie chart. All right, so once it's a pie, it's always a pie, so you cannot change it later. So if you're trying to build a pie chart, this is the time to select that. Same thing with bubble series and spread spectrums and radar. right? But line, area, column, bar, these are interchangeable, and we'll see it in a second. So, okay, and basically now you get your default components, which is a series. You have one series at your one vertical axis, one horizontal axis, and plot area has remained there, so it's still there. Right? And under series, you can go back and change series type between line, area, column, and bar, like I said before, but you can no longer make it a pie chart. Also, you cannot mix pie series, for example, with line or area series. So those are not mixable. So that's just a limitation. So that's how you get a chart into your page. So next segment, we're gonna go over some styling properties. All right, for this segment, we're going to create some history, and we're going to use the history as our data source so we can truly experiment with styling. And we'll use one of our simulated VVs to start collecting live data. So we're going to data flow, and what we need is a recorder, a real-time recorder. All right, we'll grab room temperature and collect temp, which is going to be our room temperature. And so buffer size, basically, this is a rolling number of rows that we want to fit in our live table. Time window will specify how long this will run before it starts shifting the window. So how much time will fit. It has to fit in those rows as well, by the way. And for us, it's fine. You can see it already started posting new values. Basically, as they change, it keeps posting values. So this real-time recorder works strictly on change, not on interval. However, if you do have a more or less static value that you want to record on interval, simply add another one here and link a ticker to it, right? That basically ticks every second. So like this. I know it's somewhat unrelated, but so in the stopwatch, this is kind of useful feature. So let's say this was a static value or didn't change often, but you did want interval data. So just use a stopwatch with a 1 second step, modulo of 2, right? Enabled, right? So this is going to just tick between 1 and 2. So we're going to use that for the value, which will force, of course, collection of, reset the table, which will force a collection of both values, right? Ticker, which you don't care about, it also forces the collection of your value. So this way you can get real-time recorder to work not only on change, but also on interval. Right? But that's neither here nor there. So let's return everything back to the way it was, because we're just fine with it recording on change. So this is going to be our data source. It's going to get slightly bigger over time as we give it some time to collect, but we actually force maybe the temperature to start changing a bit more rapidly. Let's do cool the room down real quick and see what that does. So let's see, the heating should come on and it should start heating up. So while it's heating up, let's start to use this data to drive the chart. Close all the windows, and we're going to add a blank chart to the page, and we're going to use our table to plot the temperature. Of course, our column being plotted is the temp, and it is a linear axis, and it is a history chart. We do have a timestamp, and for that, datetime axis and timestamp column, of course, is what we need. We'll keep this aligned series, and just hit OK. Right, so this generates a chart, but this chart is not exactly a looker. So let's see what we can do to make it, to do some basic tweaks to make it consumable, at least digestible. First of all, the lines, they're way too prominent. You'll find them under plot area right here, horizontal lines. Typically, you would just reduce their opacity to something barely noticeable so they're somewhat out of sight. Here you can also add uh, basic lines, vertical lines, or both, which will create lines on tick marks, both horizontal and vertical, if that's your desire. Here you also have some feedback. You get information about the plot area. So this is zoom. Sorry. So let's go back to here. Plot area. So you get X, Y, width, and height. This is literally start of this plot area rectangle, right? X and Y, and then width and height. This allows you to match something to the chart size. So if you're trying to have a custom background or show some other graphic behind the chart, these coordinates and sizes will help you size your group to match the plotted area exactly. Of course, they're dynamic as the chart is resizing. You would notice that so do these numbers. Okay. Here under plot area, you can also enable zooming. So zooming allows you to drag to zoom into the chart. By default is disabled, so I cannot drag or zoom in. If I do enable zoom, so for example, vertical zoom, right? This allows me to zoom in into vertical scale. Double click, of course, zooms out to original. Then horizontal, of course, will do the opposite, but on the horizontal scale, like that. You can control, of course, the color, the overlay color, and the outline to style how zooming rectangle looks like. So let's set it to be a bit less prominent, and I don't know, let's say something like this, right, to match the chart. And you can also do both, which will allow you to do either or, right? So you can drag this way or this way. And of course, the rectangle will allow you to literally draw an area that you want to zoom into. So you have to keep in mind that once, if it's set to none, you can zoom out. So you have to make sure you return to default before you change it back to none. For whatever reason, you may do that. And of course, zoom all axes will, if you have multiple series with multiple axes assigned to each series, this will control whether all of them get zoomed in or just the top one. Right, and a few more zoom parameters. You can specify min max and trigger. This is to create logical zoom, right? Where in addition to giving user ability to do this by dragging, you can also set these numbers and invoke the zooming on event. Right? So we have a chart zoom in automatically, for example, if alarm is detected, on some time frame. You can do cool stuff with this. So, so this is that's about all you can do in the plot area. One thing to keep in mind: things like tick alignments, they only work against the first series if you have multiple series. So here I only have one series, so that's not a problem. However, if I had plotted more series, the plot area will only align the grid lines to the first axes, right? Sorry, not first series, first axes, right, that are used in the first series. Again, so I have one of each, right? I can have more. However, the tick marks, the grid lines will only align to the first one in the list. So you just have to keep in mind when you build and style stuff. So next, let's take a look at labels. Now this table doesn't have enough data yet for them to bunch up. So let's make them bunch up like this, right? So how do we solve this issue, right? So if you have very granular data, all right, or lots of timestamps, um, how do you fit them nicely, right? By default, it has to show all of them, and it will shrink and reposition and just do weird stuff with them just to fit them in some way. So here's what we can do there. So under series, of course, sorry, under appropriate axes, not series, for horizontal axis, for example. So we select axes. Now the default settings for labels show all, which is why it has to do this weird dance to show them all. The typical approach would be to switch it to auto, which means it'll fit as many as fit nicely over here. You can also do min max depending on which chart type you're building, but auto suits most situations. And of course, when you start styling, this is where you can change the font coloring, font sizing, and various other aspects about your chart look and feel. Also on the axes, you control the axis line itself. You can see that by default it's pretty prominent, and tick marks are rather kind of in your face. The typical approach that I take there is to reduce kind of prominence of the tick marks at least. So we're going to expand under the line color. We're going to expand this little sub section, and this is where we can control. Let's see, what am I doing? Oh yeah, cross marks. That's what we're doing. So here you can see the major, minor cross marks. So for right now they're set to cross. I tend to like to have them just point inside like this, both. Again, this is dependent on the design requirements, but this is where you would change that. And also, if we do have to have both, sometimes I just turn the minor off. But if you do have to have both, again, making them a bit less intrusive and less kind of, less in your face is always a good idea in my book. Something like this, right? And of course, the same can be done with the vertical axes that we've just done. And kind of the idea is exactly the same. So side and side, make this less prominent. Going to reduce the contrast a bit because we are, trying to join white on black, which, again, is not, I think, distracts too much attention from a chart data itself, right? And draws too much attention to various helpers around the chart. And the size of tick marks like this. So same can be done, of course, with labels, right? Show all is there by default, so we can do auto. Now there'll be no change yet, right? Because they all fit nicely anyway. Min max also always a good idea. It's in my book. And smaller fonts will help this one particular one to not be so annoying, right? So these are kind of the basics that you start with to get the chart at least to look sane in your page. Don't forget that it does not have a background, so if my stage background changes right now, right, all my colors now become rather obsolete, right? So if you want the chart to have its own background, don't forget to give it such. Right? There. All right. So next, let's take a look at some other things you can tweak on the axes, namely the format. Now here we're dealing with the timestamp scale. So we'll naturally be interested in formatting the time. So you can find it again, and it's just the same section where we control the tick marks, and this is the default situation. So date format local means it's going to assume that the timestamp data you're feeding it needs to be displayed in basically local time. So that's wherever your browser is basically. If you switch it to server, then it's not going to try to make the conversion. It's going to assume that whatever timestamp the data comes in from, that's what needs to be displayed. Right. Again, if this of course is if your timestamp comes with it. I mean, if your date times come with the time zone in the first place. Data units. So it's going to be auto by default, which is why here we have seconds because we have pretty small. No, sorry, these are minutes. We have small data intervals here. You can manually change them. You can also create logic and bind to these, so that you calculate your own interval and adjust this, right? So something like this, for example. The hours, of course, give me one interval, which I haven't crossed yet, and the seconds will give me a lot of intervals. But as you can, because it's auto, notice that it'll have as many as it can fit, but no more. It's not going to mark every second. It would, however, do that if your labels were set to show all. This would be pretty. Looks like it's not even going to try to do that, or it might be actually trying to render them all. Let's not overload it. Actually, probably maybe not, because our data doesn't come in every second, so maybe it's not so bad. Anyway, so let's get back to what we were doing here. So again, date format, data units. Let's go back to minutes. Interval, right? So right by default, it just recalculates or automatically calculates the interval. You can set it to be specific. For example, every 5 minutes, right? That's a given. Right. So if you normally chart will auto adjust the date range is displaying based on data you're feeding it. So what's in the table, however, you can force it to only show specific date range from the available data table. And so if we do that, it's going to stop kind of moving itself as time progresses. Right? With auto adjust, of course, since our table gets constantly expanded as new values get posted, so does the chart here. Right? Going down here, so these are feedbacks for you. So these are read-only values that you can use. This is a calculated minimum, maximum timestamp. These, of course, are milliseconds, the epoch time. Computed interval, right? So if we of course set it to 5, right? But if this was set to 0, basically to be auto, then you get here whatever the calculated interval happens to be. Right now it's 1 minute. Right? So these can be useful in your own logic, right? If you need to supplement the chart with other elements, and it's important for you what chart is showing, so that your other display can match this. So these numbers these properties is what you would use. Again, you cannot set them; these are read-only, so you can use these values in your own calculations. And of course, the computed units, right? So if you let the chart figure out the format of your timestamp and what units should be displayed based on how big the date range is, it gives you that feedback as well, so you can use the same units in your other display widgets. Show zero label. It's a given. It doesn't always do much for date for timestamp series because you don't always have the zero time in your table. But this would control whether zero is shown or not, because of course you would also have a zero in your vertical axis. So just so you don't have zeros right next to another zero, this is the option here. But again, it doesn't do a whole lot in the timestamp axes. Okay, so the rest are kind of standard properties. They're not specific to the axes. These are just same properties you find on all the components. Not all of them do much because you can't, of course, just take and move your series anywhere you want. So typically you would never really touch these. Right? And that's it. Of course, you can change alignments and placement and all that stuff. That's a given. I think that's pretty self-evident. Gaps are also useful when you try to style a chart very specifically. You can control a distance between kind of the chart and labels and edge, right? And a few other aspects, right? So you can make it look very custom if you really wanted to. Standard custom labels. This controls whether you want to use your own symbol for the labels. Of course, standard is a text, and we saw all the options for that. If you have your own symbol that you want to use as a label, all this is where you would specify that symbol name. Okay, well, so that just got us through the axes, and there's a lot more to cover here. So let's quickly dive into series options. Well, for series options, we of course go to series, and here we are, and let's go through this. Let's try to do this fairly quickly because there are more axis options that we need to cover for different types of axes. Anyway, so display name, of course, is a display name, and it shows up in automatically generated data tip, and you can have it displayed on in various places, depending how you're plotting this. Series type, of course, controls the series type. You can switch between them. The styling will typically get preserved. There's a separate set of styling components for each of the series types. You saw that when I switched to area series, I got the kind of weird default. But as I switch back to line, right, my line series styling is kept there. So if I style area series, let's change the, let's say, fill to something that's not as in your face. All right. And now let's try a change between area and line. You see that it nicely preserves styling for both of them. And you can keep in mind as you when you build your widgets using charts that you can actually pre-style, all the types, and let the user switch between them. Yeah, you may find it difficult to bind to this property to dynamically change the chart styling or chart type, but you can set this through a state block. So one more thing to keep in mind that as you bind to things like outline, if you bind to this color to control it while in line series, when you switch to area series, you're not going to have that binding because technically it's a different element. You just switched between two elements, one being components, not elements, sorry, one being line series, one being area series. On one hand, that's why the styling is preserved. On the other hand, the bindings get changed as well. So just keep that in mind. So line form, of course, this is a nice touch. So it can be just a segmented. In our case, we have quite a few data points, so we may not see a whole lot of difference between the segmented, for example, and curve. But if you don't have as granular of data, Right? Changing to curve would, of course, make the line much smoother as it interpolates between the data points. And then step, reverse step, and all that stuff, of course, make it a stairwell looking line. So you probably know what you need to do here. This is not so much kind of aesthetics as it is kind of requirement that you may have for your project. So I'm not going to get any further into this. I think this is self-evident. Data tip, of course, controls whether you can or cannot see the data tip with a data point. Data tip shows up on every data point. It will not show up in between data points. So if there's a line item in the table with this timestamp and this value, it will show you the data tip when you mouse over it. If there isn't, if you're in between the data points, you're not going to get a data tip. So you don't just get it kind of by default everywhere on your plot line. You get it at your data points. Where are the data points? You can actually see that by enabling markers. By default, they're none. So if you enable standard markers and give them a radius, for example, 3 points, you can see I have so many of them that, that they just blend into one continuous line. But if we zoom in, which we need to enable the zooming, let's enable. I already have horizontal zoom. That's fine. So let's go ahead and zoom into the chunk of this. Zooming in. There you go. So these are the markers. And let's go back to the series. There. You can control the radius, of course, and the fill, right, and the outline. The reason it's kind of nice to have a control of the outline and the fill is you can do something like this, right? Where rather than just dots, you can have empty kind of filled dots and stuff like that. So a lot of cool stuff you can do with markers. Now you can also use custom markers, which is basically like everything, use your own symbol. Right? It's going to get placed where you would find a marker. What it looks like is completely up to you. Let's go back up a little bit. Data tip. This is how you construct this this data tip pop-up. There's a very nice kind of help tip there, giving you the format and various syntax you can use to get it to look the way you want. The nice part is here's what it looks like. The nice part is that you can reference other columns from the data table even if they're not being plotted on your chart, which is kind of nice. So this just refers to x value, y value, but you can actually reference directly column name directly here, if I recall. So our column name I think is temp. So I think you can do something like this. Yeah. So look, so this is referencing a column directly. So in that column can be any column from your table. So we can actually have, for example, column row, because we don't really have any other columns, right? Make sure to apply. All right, so look at this. So it shows you the row number and then the value. So keep that in mind. So if your table is a large table containing more than just simple value and a timestamp, you can insert your various help tips and descriptions and whatever else, right? So you can construct really elaborate data tip using this syntax here. The downside, you don't have a whole lot of options on the styling data tip. However, you do have an option, of course, of using your own, which is again done by supplying your symbol. And so, symbol in this, your symbol should be able to, of course, take an input of whatever you're trying to display, and it's going to be your responsibility to do that. But if you were keen on making it look exactly how you want, and the default styling just doesn't cut it for you, well, this is where you would do it. Okay, so let's keep going down. So data source, this is where you find, of course, the data table is bound to your series. And if this is a dynamic series, which we're going to spend a good chunk of time on later in this video, this table would be not your original table, but rather a surrogate table of just the column for this series and the timestamp. We'll look at that a bit later. And of course, selection of which axes to use for horizontal and vertical. They're not nameable. They also don't always go in an order they show up in the outline. So sometimes it's somewhat of an experimentation if you have more than one axis to pick which one this gets plotted against. Series animation. This control is basically so when a chart gets created, this would control. Yeah, it does that, right? So right now it animates the chart because we have a whole lot of data points in this chart. So it's instead of just they all showing up at once, it animates like this when a chart first gets plotted, and it will do that every time a new data point is posted, as I recall. So maybe, that's probably not something you want in a data intensive application, but it does add a nice touch for a little more summarized charts. And of course, your colors, of course. Okay, so that covers the series options. If we quickly take a glance at the kind of chart itself, there's not much you'll find here other than basic rules on data tip position, right? So whether you want data tip to show up right in the middle of your data point, under it, over it, and so on. Mode, right? If you select multiple, if you plot in more than one series and various series have data points that are close enough in proximity of your mouse, it will display multiple. Now, it will not by default display all of them across one timestamp, right? That's going to be if that's what you need to create your own custom tooltip symbol and display that instead. But if there are a lot of lines, for example, bunch up around your mouse, when you mouse in there, it will display all the ones that are in close vicinity so that you don't have to try and nail down one specific one to see its data tip. All right. So down low, then fill and line, all that stuff, that's no different from any other component, so I'm not going to get into that. So as you can see, not many more options you have here under the chart parent container. Okay, that's it. So we're through the basic styling properties for all of these components, and now we can start looking into the interesting stuff, which is dynamic series. Okay, so to construct dynamic series, first we need a data source which contains more than one value. So we're going to create a dynamic history chart, meaning that we're going to have one common date time axes and multiple series plotted against that. So we need a data table that would do that. We're going to expand our real-time recorder to record more stuff. And basically, let's add a few more columns. I'm not going to get too creative here, so we'll do value 1, value 2, value 3. The reason I'm not using other VVs for this is because you can see the changes for VV room temperature are pretty slow and very increment by very little amount, and I want my data to vary drastically instead. So I'm going to use a stopwatch with various multipliers so let's do modulo 50 to simulate the rest of the data. Right, so this once a second is fine. So we're going to use a multiplier of 1 for this. Multiplier of, I don't know, 1.5. this. Maybe multiplier of 0.5 for the third one. Reset everything, and we get something like this. Yeah, something like this. Let me just reset it one more time. There. So, all right. So we have 4 columns. Now I could, of course, drop a series there 4 times and chart with 4 series. However, if this table happens to be dynamic, for example, something that comes via get multiple history block, where you can dynamically string together history paths, and it'll fetch it in something that looks like this, basically single timestamp and bunch of value columns. That means you cannot pre-configure your chart with specific number of series because you don't know how many series you will have. So if you build a user interface where the user picks what he wants to plot, you don't know if he picks 1 or 10, so you can't really pre-create this series. So what do? Well, what you do is you create dynamic series. So let me explain. I'm going to delete the one that we have. Right? I'm going to keep axes because they work just fine for us. So to create dynamic series, I'm going to grab any one of these columns. It doesn't matter. Drop it. So I'm going to basically set up my axes. In this case, I already have X and Y axes. So I'm going to just click use existing. Of course, timestamp for the timestamp column value. That's just going to remain. This one I don't care about. I'm going to check dynamic here. Okay. So let's look what happened. So it created master series, right? So you don't see 4 series here, you just see master series. But what really happened? Obviously, you see 4 lines in here. They're styled the same, so maybe that's not cool. I don't know. Well, let's see what we can do about this. You cannot style them separately because they don't exist separately. They get rendered, they get generated on demand. So the master series looks like a prototype of a typical series. But however, any changes you make to it, right, and of course apply. Now you get this extra master series set of properties at the very bottom, where you can just update whatever changes you made. But it applies all the updates to all the series, so that doesn't help us to make them look different. But don't worry, we'll get to it. Let's first explore what it looks like here. So it looks like every other. It looks like every other series. So except this doesn't refer to one specific series; it refers to all of them at the same time. So of course, line, the type of series, line format. This is by the way where we can probably see the. Actually, now we're not going to see the curve here because again we have a lot of data points, so they just force that type of shape. Right. So data source. So you no longer see a binding to the data source. You can look at it, but look what it looks like. X, Y, index. We didn't have that in our original table. So what really happens is it takes our original table and splits everything into X, which is for always our timestamp, and Y, which would be different column based on what series you're trying to render. Right. So here under master series, you can basically change, or not change. You can see what which index, which series you're currently looking at. Right now it's 0. So series 0, first one out of 3 series, is going to use column temp, and that's what we're seeing under Y. Column Y would of course use the next column, whatever that name is. Val1, Val2, and so on. Yeah, so hopefully you see the problem, right? This doesn't let us style any series separately. But let's explore what else we have. So we also get a series subgroup, which we didn't have before. So we also used to have series right under the series group. Now we have series subgroup, and only under that we have a master series. So what's a series here? Well, this basically is a parent for the dynamic series. It's a series repeater. So if you recall how a repeater works, with either visual or data flow, right? You have your data source, and then you have your render, which is the component prototype. Same thing here. So this is your repeater, right? And this is your prototype of what you're repeating, basically a render. So repeater, if you expand this as a data source, that's your table, right? That's our data table. Underneath, you need to specify basically what column controls what and what are the rules. So for X column, we have only single column, right, which is our timestamp. We only have one timestamp, right, and that's where it's specified. The column, we use column timestamp as our X column. For Y, the rule is all other columns, right? So that means every other column it finds other than the timestamp, it will plot. Rows, I think, excluded by naturally. You can also include other columns. I think you can force it to be included. Let's see if it's going to have an effect. Yeah, yep. I think it's it's probably trained to never trust the row column. Anyway, but if you had, I guess, other well, in this case you wouldn't have other columns because your rule is all columns. However, your rules can change. For example, you can have one column, in which case you specify which one it is. Let's say if you want to just plot value 1, we'll just plot that one. If you want an additional column, val 2, and maybe val 3. I think that's the syntax. I might be wrong on this one. Let's get back to it in a second here. So one column list, right? This is where you specify which ones. Yep, there you go, val 3. Right, so you can comma separate list of what you're trying to plot. I actually don't know what additional column means. I don't think I've ever used it. But well, maybe I'll find out later. And of course, exclude columns means it's going to plot everything except for what you list to be excluded. So let's give it all other columns. That's your default. That's how you find your dynamic series to be created by default. So we'll just keep it at that because this suits us well. Keep in mind that normally if your table has a lot of stuff besides what you're trying to plot, then you just need to make sure you either explicitly include what you're trying to plot or explicitly exclude what should not be plotted. Just keep that in mind. Now our table doesn't have anything that should not be plotted. Right? Every column here is being used, so I don't need to worry about that. All right. So when this is done, repeater basically generates a master series, and each instance of a master series gets, of course, a surrogate table based on this original table where X column becomes timestamp and Y column becomes, well, one of these, one for each of the instances. One important thing is stacking, right? It's stacked by default, meaning that they're additive, right? You see that they don't, well, without fill, maybe it's a little bit difficult. We'll make them filled in a second. But these are added one onto another, right? So if you need them all of them to be plotted against the same coordinate system without stacking on top of one another, you have to change this to overlay, right? This is how it really looks like. You see, so this is each series being plotted against the coordinate system without others affecting it, but by default they're stacked, right? So they show you a sum of all the series at any given timestamp. And of course, you can do 100%, which just shows you the ratio of each one in percentage terms of all between all your series. So let's get them stacked. Okay, now we're on to the cool part: is how do we style them separately? Let's change this to line, sorry, area, just so that we can play with the fill. And this may not be as intuitive as its other things, so follow along here. Okay, so this is where styling needs to happen. It has to be on the data flow of the master series. So we're going to go here. Right? And here you can create logic that's dependent on which specific index of basically which series out of this render, basically out of master series, you're trying to style using your series index property as your differentiator. So what I'm going to do now is I'm going to create myself a table, and I'm going to store some colors in here that I want to use. So I'm going to say color. Now, based on how many series you expect to find in your chart, this list may need to be longer or shorter. You can, if it's short enough, you can use a case block instead of using a table. I'm going to use a table. And I'll just get a color block and start copying some colors. So let's use green. Let's use yellow fish, orange, and pink. I'm going to do more than I have because I have 4 series. I'm going to do 5 colors, so that you can see how they come into play as I have more series. Maybe let's even do more. We'll use this purple. Okay, so that's going to be my color array table. Mouse is having problems. There. So I'm going to go to the data flow of the master series. The reason I created this table on my page data flow rather than master series is to show that this can come from outside, right? Sometimes I would have, not sometimes, more often I would actually have it in the project data flow as my standard color palette, right? So that all the components that require multiple colors based on series draw from the same color set. So let's go to the data flow of a master series. Right, and we're going to filter this table. We're going to get a row from this table, from our colors table, that corresponds to the index of the series that we're trying to colorize. So this would mean that we need select rows block. We could use filter and create filter expression where we insert row number, but this is just much faster. So it's going to, input will be, of course, our colors table. And then the index, the row that we're trying to get, be the series index of my master series. Like that. Right? So this will always return, well, in Designer, it will always return row 0 because I can't take a look at any other series. I always look at series 0. But when it renders, each one will get its respective color. So we have one color as a result, basically one row from this table as a result of this selection block. And we can use this to bind, right, to a color of the fill. So notice I didn't bind to the whole fill. I actually brought up kind of fill dialog, and I only brought up a binding for just the color, the physical color, not the whole fill. And now I can actually reduce the opacity on the fill. Right, so that's going to be my fill. And for the line, Right? I'm going to go in here and again bring up the color, only the color, right? Not the whole fill. So only bring up this blue dot for binding. Bind the color to that. Right? So that's going to remain 100%. So we're not going to change the opacity there. I'm even going to make it a little bit thicker. Right? And now when I'm done, I'm going to hit update. Okay, so look what just happened. Right? It took, for each of the series that it renders, it takes a corresponding row of my table, right, and uses the value to drive the fill, right, for the at 50% opacity for the fill, and of course 100% opacity for the line. Right? Let me reduce the line size. I don't like the 2-pixel line. This looks more neater. Okay, so that's how you affect the styling of each of the dynamically rendered series separately. So the logic has to be on the master series. So you cannot place this data flow here or here or here. It has to be in the master series because only on this data flow will the series index become relevant only to the series that you're affecting. What really happens, right, when it actually physically renders the chart, it takes this master series and renders basically a copy of it, in this case 4 times, including its data flow. But each one of those copies will have this index correspond to that copy. So index 0 is this. Imagine one underneath with index 1, then another one with index 2, another one with index 3. They're all going to have a copy of this data flow, but in each of those data flows, this value that selects which row to use will, of course, change because there's a binding from this to this. And that basically is what lets you style these dynamic series separately based on that index. And when I said you could use case block, what I meant is, right, the key here is not the table, right? I'm just using table as a way to deliver the data, but case block will work the same way, where your input will be your series index, and then for case 0, you'll bind one color, case 1, case 2, right? The problem with case block, it's not scalable easily because you would need to pre-create as many cases as you expect to have series, and if you don't have a limit on how many series you have, if you leave it up to the user, well, you just can't have an endless case block, can you? Right? So this limits usability of case block in this case. However, if your requirement has a hard limit on the series, for example, you'll always have up to 3 or 5, right? You could easily use a case block and just bind a different color to each of the cases and bind the output to the fill like I did with a table row. Right? So the key here is not the table. The key here is ability to pick a color or any other attribute based on the index of the series. Right. So that's how you style this. The same method. Now we only, of course, dealt with the fill color, but same exact method can be used for anything from datatip syntax, right, to, of course, well, naming is already done by column name. That's supplied by default. But yeah, you can even change the series type again, but you have to use a state block to set it, not a binding. It won't allow binding. Right? You can change other aspects of the series. I can't think of many, but I mean there are cases here and there where things like, for example, one maybe should have markers and one should not. Right? I mean things like that. So yeah, hopefully the concept of styling dynamic series is now clear to you, and we can move on to other chart types that don't fit this particular pattern, which would be pie chart and bubble chart. So let's take a look at pie chart. It's slightly different beast compared to other charts. I'm going to start with kind of one pre-configured pie chart rather than a completely blank slate. I find it easier to do that way. But of course, it's created in a similar way as we did with this one. And there are several things that are worth paying attention to in relation to any other charts. So this is how the data looks like. And so this is what we're feeding to this pie chart right now. We're not plotting everything here. We're just, if we look at data binding, we're just plotting the X field, right? So 10, 30, 58, 10, 30, 58. Pie chart, of course, plots single column, single value. There's no historical aspect to this. It needs a column, it needs one column, right? So filling, right? So we number of wedges, of course, is always dynamic, right? And it's related to number of rows you have in your table, right? So as you add rows, you'll add wedges. So how do you control colors? It's not done the same way as you do in the dynamic chart, because this is not really a dynamic chart. So under series, this little subsection called wedge fill, and here you can generate an array of colors that is going to cycle through. Right? Again, this works well if your number of wedges is somewhat known, or at least limit is somewhat known. It will, as I recall, it will start cycling through these if you exceed. However, you can actually, if you truly have unknown amount of wedges and you have some algorithm that generates colors, you don't want to repeat colors or anything like that. So you cannot predefine these, because if you have 50 wedges, who's going to sit here and predefine 50 colors, and then next time you have 51 wedges, and well, what happens? You're short on a color. You cannot do this dynamically either, right? So you cannot somehow hit this add button dynamically, programmatically to add these on the fly. So they can have to be pre-configured. However, the alternative, of course, is use color field, right? So here you can specify if your table contains a color, and if you generate those colors via some clever algorithm, and you would join your color table with the data table, so you would have, let's say, a color field here, and well, geez, we have a color, so let's do that. So here I'm going to delete these columns, which we're not even using, and I'm going to go back to this page data flow. Right, this is our color table. Bring that up. Go to pie chart. So this is the table we're plotting. So let's join this beast. That against that, and of course we're joining on row because we have no other common fields. It's going to be left join, so everything from data and whatever is matching from our colors table. So this should give us, yeah, it gives us this, right? So we have value and the color. So now if we plot that, so we're going to bind this to the chart instead of just the table. So visually, it's not going to change the chart yet. But if we go back and say, we were here, yep, and say now our color field is color, right? Now it's drawing from our table that contains the color next to each of the value rows. So you can dynamically introduce new colors to a pie chart that way through the data table. There are some other interesting styling aspects to the pie chart. Of course, explode radius is always cool. However, if you go too far in this, now explosion is relative, of course, to the wedge size. So you're not going to get perfectly equal distances there. That's just the nature of explosion. So if you want perfectly aligned separations. What I tend to do is, instead of using explosion, I use give it a wedge, a border, right? That's say that fits the background, right? Something like this. This, of course, creates the exactly, you first of all, you preserve the exact circle shape, right? Where when you explode, of course, you lose your circle shape. You can see that they start, the radius of each of the slices gets reduced, so your overall shape becomes bulbous. So to preserve that, I just use um, the outline, the wedge outline, to preserve this with a, in this case, black stroke, so it matches the background somewhat and so on. You can also do control inner radius. Now, the styling properties are kind of spread well throughout the pie chart hierarchy, right? So some of them are in a very parent pie chart, and here you can do things like inner radius. So if you were wondering how to nest one chart inside the other, this is how you just set inner radius and create another pie chart and nest it inside. Outer radius, of course. Data tips, right? So that's, of course, what pops up when you mouse over. And then you have position, of course, and then you have your callouts. Now these are sometimes painful. They're controlled in the series, if I recall. Let's see. Sources, animation, labels. Yeah, labels is what they call it. So, their placement is always, of course, I mean, it's a fairly complex algorithm, and it will, whether you want it or not, affect the size of the pie chart, because the length of your text here and how many wedges, meaning how much it can fit in here, they all, of course, play a role in how much space labels need, and that will control how much space you have left available for your pie chart. And so if you, for example, styled it nicely with chart being this big and you nested another one inside here, and then your values became longer, have more digits, and you then notice that, well, nothing aligns anymore, right? Your inner pie, like this pie chart is sliding under your inner one, and things going every which way. And that's because of labels. If you're trying to have perfectly aligned pie charts, if you need to center align it with something, or nest two pie charts inside each other to create this double ring kind of widget, you cannot use labels. They will throw your sizing off every time, because they ensure that your pie chart circumference, basically the radius, becomes dynamic, right? And it's controlled by the label length and their quantity. So if you're trying to have that not change on you, well, turn off labels, right? Create a legend of your own on the side somewhere if you want to. Use some other methods, but just disable labels on the pie chart itself. Of course, data tips are no problem. And so just an example of a nested pie chart, of course, is one inside the other. They can be exactly the same size, and you can control it by reducing the outer radius like this. There you go. So that's one way to nest them. And of course, I'm using the same data table, so they just basically duplicate each other, but different data table means different pie chart. You will notice that there's an issue. It will block your data tips, right? If your inner one is mouse interactive, unfortunately, it blocks your outer one, and there is no click-through, as I recall, setting. There is. Let's see if it has an effect. No, it does not have an effect. So it will block the chart underneath. So if you're relying on displaying the data tips, nesting charts is not a way to go. Even if you nest using the size, meaning you reduce the actual size of the chart, not just radius, but actual size to be inside the other one, the corners of your rectangle space will still kind of block off chunks of your outer pie chart. So unfortunately, that's not a way to go. You would have to kind of say bye to your data tips if it's important to you that you nest your pie charts. All right, so let's get rid of the nested one. Go back to this one. So beyond this, there's not much else really that requires a lot of attention. So fill and stroke. That's just the pie chart for the whole ring, right? So this gives you a nice. I mean, it's just another option to get it to look exactly how you want. And that's it. I mean, selection. Selection will work, of course, if nothing is blocking it, right? It just returns a row number that corresponds to the wedge that you clicked on. So row 2, so you can use this to highlight something else, for example, in a table somewhere. Why not? Let's see, what else do we need here? I mean, really, that's it. Animation has the same effect as in the chart above. When it first renders, right, it will kind of do a nice circle swoop and so on. So that's that. I can't think of anything else really that needs to be said about the pie chart. Of course, you can use custom renders for data tip and for the label, including wedge labels if you're displaying them. Of course, we're not displaying them. So that's it. So let's say we're done with the pie chart, and let's move on to another type of chart. Again, which is not as common. The bubble chart. Okay, so we're going to take a look at the bubble chart now, but through the magic of video editing, I've made the pie chart that we just created a little bit dynamic. I actually used the values that we're feeding into our line area chart above, and I made them feed our pie chart. It all looks like this basically. So I'm simply taking that all of the values from from this JSON parser. Remember, we'll bring them all to Cadence, and it looks like this. Bringing them down here to the pie chart, transposing them to basically bend them up so they're all in their one column rather than being multiple rows. And I'm then joining them with a color and plotting them on the pie chart just like we did before. So the only thing that changed on the pie chart is now where data is bound, where a field used to be X. Now the field is called value1 because, well, that's our data field. So this creates this dynamically moving pie chart. It carries no purpose for the training other than just pleasing to look at. Oh, by the way, it does show you how the animation works. It interpolates in the chart. That's why it moves kind of somewhat smoothly, right? It doesn't just jerk into new position. It actually slides. Well, that's for that you can say thanks to the series animation set to interpolate. Without it, it looks like this. It just basically jumps to the new position right away. With interpolation, kind of moves smoothly. Anyway, so let's get on to our bubble chart. All right. Bubble chart by nature is very similar to any other kind of standard X and Y type chart, except it has another parameter, which is the size of the bubble. So we're standard charts like line and area and column, can plot two values, X and Y. This one can plot three, X, Y, and let's say R, which is the radius. If you look at the chart itself, we're not going to spend too much time on this one, and here's why. If you look at the chart itself, It looks remarkably similar to a line chart or area chart, or basically one of those standard charts. Except that you don't have a selection here of a series type, right? And it has one extra field, which is R. So your data source, of course, has to have 3 columns. So you can plot one against the other, and then also use one to drive the radius. In this case, both are linear, so linear x, linear y, linear x, linear y, and then R for the circle radius. So styling properties are very close to what you find in line and area series, except you have more options here for the circle fill. So the axis type for the radius here, it's linear by default. You can make it logarithmic. Min max to control your bubble size so they don't get out of hand. Gradient mapping. This is so you can actually map. Introduce a fourth parameter. Let's see, from light green to dark green. Right, so this it will also correlate the size of the bubble to the gradient map. Right, so they're distinguishable not only by size but also by color. Color field will of course control. If you want custom color for each of the rows, and your table contains that color, like we've explored in this situation where we join, or actually in pie chart where we joined the color to our data table. All right, you can reference that in here by typing in the column name that contains the color, which will affect the bubble at that row. Case in point, let's try to add it and just see how it responds. Sometimes I want to see myself because that's not something I get to use very often, so it's always good to see. So let's, I'm just creating this color as on the fly. I don't know. I don't know what colors these end up being. I'm just typing things in. I know this one will be gray, probably dark gray. So color. Oh, I didn't like my color. Maybe these are not real colors. So let's try to make sure I got all my digits in. I don't know. I didn't like. Don't seem to like my color here. Not sure why. They've gone away. So, yeah, they're actually not physically not rendering. So maybe the color is in the wrong format. I'm not sure. I'll follow up with some of our developers. If I find something interesting, I'll report back. But yeah, I don't think I've ever used this color field, so it's hard for me to comment on that. Okay, there, let's keep moving in here. So actual bubble fill, if you're not using gradient mapping, of course, then you can make them just at the same fill. I am using gradient mapping in this case. If I reset it, maybe that's how you use color. Yeah, okay, now I understand. So you have to make sure reset your gradient mapping. You cannot have both. So either gradient mapping or color field or a fixed fill. Right. So in this case, using the color column to generate the fill here. If I blank that out, then it falls back to the standard fill. Right. So that's the hierarchy here: gradient mapping, then color field, then solid fill. All right, and that's it. So there's not much else you can do. You can affect the placement on the axes in an interesting way that don't recall if you could do this in standard um, line chart or not. I think we also could, but often this kind of placement is typical for a bubble chart. And that's it. There isn't much else in the bubble chart here that worth exploring. Like I said, because other than the introduction of the uh, marker radius and associated styling properties, it works in a very similar way to all the other chart types. Let me demonstrate and then try to solve one interesting problem for you. And it doesn't have to do so much with the chart as it does with this real-time recorder. Notice, so I've added a sine wave here, and notice the steps. Now, technically, my series is set to curve, so I shouldn't be seeing those, but I am. And let me explain why. The real-time recorder works on change of value, and on change of any of those values, right, it creates a row with each of those values as they are at that given moment. So if I can demonstrate, um, so let's take a look at some of these values. So notice, so we're interested in, of course, value 4. That's our sine, right? And you see there's a kind of tiny change, and then jump, and then tiny change, then a jump. That's what's creating those steps, right? Because it is drawing the curve, right? But it's curving between those tiny changes is basically a flat line, right? So, and then quick jump, right? And so you're seeing the steps. The reason you're seeing those is because in between each change of this value, looks like there are about 3 different changes caused by other values in here, right? So that's why you end up with basically 3 rows containing very similar, if not identical, value, right? So because all these values are not on the same cadence, but each one of them causes a whole row to be created, right? First of all, you end up with a lot more line items, rows that you really need, right? And second of all, of course, it creates these rather toothy looking charts. So how would you solve something like this? Well, we need to bring these all to the same cadence. Um, the way you would do this is somehow you make sure that these updates for each of those values are held back, right, and then released all at the same time. Now, if you're trying to use, if you try to use things like delay block, right, you would quickly find that, oh, you could probably get it to work. Let's try it, because this actually, technically, this should be one of the methods. So let's see if we can get it to work. So let's create a bunch of inputs. Input 1, input 2, input 3, 4, and then finally our sine wave. Right, notice that the last one is just static value. Let me just set it to 0, just so we don't get with it. So, and we're going to change the method to wait. Right. So this is, notice this will basically hold any updates for a second and then release them all at once. But you see that they still don't. It doesn't create enough of a cadence, right? There's still a delay, and I bet if I bind these, so let's try to go ahead and bind these. I bet I would find. Let's see. Right. Let's see if this helps us in any way. Window. Let's try window. Yeah, okay, window is cool. So window brings them all close enough. You can see that they change almost instantaneously. It's still creating, you can see a bit of a slip and slide here, whatever we want to call this, because they're close enough together. So we have less copies of a row, but they're not perfect. So if we look at here, well, let's reset so we don't have to deal with that much data. There. Okay, so yeah, so you can see, so the change interval is not uniform because, like I said, the cadence is not perfect, but it's much better, as you can see, right? And the curve mode smooths it out as best it can. But let's explore another method that theoretically should produce much better results. So what we need to do is make all these values into a single value, then introduce a cadence to that, and then break them back into separate values again, and then plot results. So now this is a lot easier than it may seem. So I'm going to use make object block. Right, I'm going to add as many items as I have values. 1, 2. Well, let me just start naming them right away. Value 1. Value 2. Value 3. Value 4. And value 5. Okay, so I'm gonna again do my linking so that all the values are fed into this. So this creates a single object, right, like this. Right, then I'm going to use the delay block, right, to introduce a 1 second cadence to this. So I'm going to do wait window of 1 second and use the whole object, push it through this window. So it's gonna basically update it exactly 1 second every second, and even if it changes more often, it'll still hold those updates and only do once a second. And then I'm gonna break it down again. So just parse JSON, JSON parser input, which basically gives me, this time they're in the form of a table, but not a big deal. And I'm going to bind these back to my history block. There. So let me keep this delay block so it doesn't confuse anyone here. No, colors table as well. So now let's see what that did. So let's reset. Now we should see perfect 1 second cadence. So the intervals between values should be identical, always 1 second. And our curves should no longer have all the dimples and bumps, and you can already see that happening. Right, so notice how perfectly smooth. So the reason that's happening now is if we look at our data, right? So we're gonna have pretty much perfect 1 second cadence. You can see there's a slight difference in milliseconds, right? That's of course not visible to the naked eye. But we have perfect data, 1 row every second, right? And there's nothing in between. So you don't have like 3 updates almost next to each other and then 1 and then so on, because we no longer have each change in each of those values causing a row, but rather we wait for any changes that can make it into 1 second cadence, and then that creates a new row, right? And if the change didn't make it in, it makes it into the next row, right, in the next second. Resulting, of course, is this great, perfectly smooth sine wave. Right, and if we change this to stack, that will look even cooler there. Right, so one last type of, I guess you can call it chart that we haven't explored here, we already had a whole episode on, and this is SVG repeater. If you do insert menu and look under charts, raw SVG repeater here is listed as a chart. It's not really, but it's flexible enough where you can make it do the duty of a chart, because all it does is just plots geometry on a in a field. So you can get it to plot, of course, lines, curves, shapes, and so on. So that's why it's under chart. I personally would probably categorize it somewhere else, but it's there and it can be used. Now that we've gone through basically all the chart types that you would typically come across, now let's explore some kind of maybe less obvious tips and tricks and frustration points maybe, um, that that you can come across, and let's try to solve them. One, of course, being that when you need to interact with the chart content, display something over it or under it, and it needs to match the plotting area. It may not be. It's not as obvious as it may seem, right? Because the plot area will change, right? As the numbers, you can see that as numbers shift here, as labels shift, as label length gets changed. You see that it does affect plot area, right? So the spacing here, changes here and there. Again, the on your y-axis, right, the length of these labels will also take up different amounts of space based on how big the number is in this case, and it'll kind of change your plot area. So you can't just go and place something right over it and just say, okay, that's going to be my overlay. But we've already kind of gone through and I've shown you that the chart has a plot area output that does give you those coordinates. So let's explore how you would use them. So let's go ahead and add just a blank group in here, and I'm going to give it an outline so we can see it. So let's do dotted here. So basically, to make this group, in which I assume you would build something that needs to match the chart, we're simply going to use plot area, x, y, and width and height. Here, to drive this group. You have to understand that, of course, that this only works as long as both the group and the chart are in the same coordinate system. And so they either have to be in the same parent, or even if they're not in the same parent, then their respective parents have to have matching coordinate systems. There. So you see that this forever placed this group to match plot area exactly, right? So if I want this group to contain some sort of call out overlay, or maybe something that follows my mouse, for targeting, whatever I choose to do here. Right, the first thing is it needs to match the plot area, and it does. Of course, the next thing is you need the ability, for example, to convert your width, your x position, to a timestamp, right? So whatever you're going to do with this group, if it involves dealing with appropriate piece of data that corresponds to horizontal position of your mouse, right? You would need to somehow translate the x position of the mouse to the timestamp. And for that, again, if we reference the plot area, plot area, it's not plot area. We actually need to go to x-axis, I believe. And here, right, this is where computed minimum and maximum timestamps really pay off, because now you just scale, right? Scale your number between this and this as scale between 0 and width, then using your actual mouse X to get the value in between. So you have everything to drive your scaling block to get your millisecond timestamp. Let's quickly set it up. I don't think it's going to take much time, so let's just really quickly look at this. So these are my min max. I'm going to go back just clean data flow to the group data flow here. This is the group that we're matching. I'm going to use a scale block. And I'm going to say that my input would be, so these will be output, of course, min max, because I'm looking for timestamp as my output. My input will be, my minimum will be 0 because the leftmost coordinate of my group is always 0. And my input max will be the width of the group itself, right, which will be this. Right, and my input will be mouse X. Now, of course, to capture mouse, I need to first get a mouse event block, and then I need to link on mouse move. This is the standard procedure to get your mouse X and Y within any given group. There it is, right? So you see that I get my X and Y as I move around. So this X, what I need, that's going to be my input. So notice how this immediately gives me a timestamp. All I have to do is format it. I do have to round it because I don't know why it does decimals there. It would definitely need fractions of a millisecond here. So just going to do a rounding of this. But I'm not even sure if date format will accept decimals. And now we can undo date format. And let's do just no, let's do date and time. So let's make this. This. That's capital M for month and lowercase m for minute. There we go. So yeah, notice what happens. All right, so I get my timestamp for every x coordinate in the group. And of course, I can use this for various things, to find things in the table, or to display it, and so on. Since we're here, and since formatting the data is a common thing, now the time zone, as you will come to hate when you deal with web applications. So default is local or auto, right? So when you get a epoch time as an input, of course, local means it assumes the epoch time is GMT, and then it applies your local time zone to it, and that's what it's showing you when you format it. Yeah, just so you can see that's my time zone there. If you do auto, it's going to carry no purpose here, but if your input had a time zone, then it would just carry that over. However, you can force a time zone. It's not obvious because you only have two choices there. But what you can do is you can construct a time zone of your liking. It needs to be in the format of either plus or minus. Has to have a sign. So let's say if it's minus, it starts with minus, but if it's plus offset, it has to have a plus, just can't skip it. And then number of hours, number of minutes. For example, let's say this is a time zone that exists, and bind it right into the time zone. Right, this will offset your time to that time zone, although it doesn't display it. Yeah, but it will offset that time. And so it's what 11:34 here. So if we do plus 0.5 0.0, right? So I got offset. So this does not introduce a time zone, right? It basically creates an offset from your input. and then displays that formatted. So that's something that goes fairly commonly with when you work with histories and so on. Okay, so I think it's clear how you align things to the plot area and how you obtain certain information from it. So let's move on to the next element. And well, next tip, or I guess how to, has to do with category axes, which comes in handy when you're trying to plot enums and booleans, basically things that have words for values, not numbers, right? So when you deal with non-linear axis type. So let's quickly set it up. I'm going to use one of the pre-configured line charts to do that. Right. So I'm going to go into my data table, and so we do need. Well, yeah, we do need date time. So let's do this properly. So I'm going to use a stopwatch, right, to just cycle between three things. Right, it's going to 0, 1, 2 move, yeah, and I'm going to translate that to a state. So case 0 would be alarm. Case 1, let's say, will be stop. Case 2 will be start. All right, and I'm gonna create series recorder. Um, field will be status. And yeah, something like this, right? So our data looks like this, and let's say this is the status of some equipment. So I'm going to go ahead and plot it. So what I'm going to do is, for this chart that we've created, I'm going to delete the series here and delete both of them actually, and just plot status. All right, so timestamp is fine, and datetime, that's correct. For this one, let's go. So it's going to create two new axes. So, however, this is not linear. This is going to be category axes, and of course, status is my category. So something like this. Actually, I have too many. Okay, let's do this. Just so we don't have to go and start clearing out this chart, let's start with a truly. So we just. Where's that logic that I just created? Is that on? Oh, oops. So before I delete this chart, I'm gonna save this this here logic. So I'm gonna Control X. Now I can delete the chart. Insert the blank slate chart. Go back and paste this logic. And then plot the status. So datetime, right? And this will be category axes, right? And status is the value. So like this. Now, when you deal with category axes, start, stop, alarm, it is common that you would. So the line will be, instead of a segment, will be a step or reverse step, depending how you prefer it, right? Of course, let's go in real quick. Change auto to the amount of labels, just because it's holding the eyes there. I'm not going to go through the motions of styling this. Here's what I want to show. often you would have particular requirement on order of things, right? So right now, the way they're generated and displayed here is however they're encountered in the table. So it looks at the data table, which is, of course, this, right? It goes like down. It's like, oh, found alarm. There it is in the bottom. Keep going. Oh, found stop, right? Get plotted one above that. Oh, found start gets plotted above. But let's say you have a specific order and you want it to be the other way around. You want it to be like, start, stop, and then alarm on top. Well, so you do this by changing the data source for your v-axis, right? So if you look at v-axis, now remember there's a category axis now. We haven't looked at those yet. It's not a whole lot of different, but when you deal with the category axis, first of all, it makes total sense to show all because they're your categories. You'd want to see them. And then in addition to all the styling stuff that we went through, there's a separate, basically, place to bind your data provider. By default, the same data table is linked, right? So it just linked the same exact table, and it says, okay, category field is the status field. That's why the way they're plotted here is the way they're found in this table. However, just so we don't get too many data points in here, let me limit to how many we get plotted in the table. Yeah, so they don't get any squished any more than they are now. So what this means is you could actually have a separate table containing your categories, your options, to drive this category. Now you have to make sure the values match, but it doesn't have to be the same table. So if I have a table, right, delete these, right, and this would be my, let's say it's called options. Right? Remember, like the first thing that it finds, it will, it gets posted on the bottom. Look how it's changing the order because it keeps removing the row as it reaches the 100 row limit. Anyway, so I'm going to add them in the order that I want, right? So instead of alarm, stop, start, I'm going to do start, stop, alarm, right? And I'm going to use this table, right, to drive my categories. So I'll switch to the axes. That's my category axes. And I'm going to bind this table there. And instead of status, it's called option or options. Okay, so look what happened. Now they're in the order that they're found in this table, right? As a matter of fact, if there's certain values for the options that I don't want plotted, my table, for example, has alarm. Let's say I only want to plot start, stop. I can actually remove an option from here, and look, it does not get plotted. Right, so I can control what I want to plot from my data table by using another table to supply all possible category options. So only what matches between your category table, which is this, and your data table will get plotted. Again, by default, when you just create the series, your data table is what's bound to the data provider for your categories. That's why they match exactly. However, this way that you cannot control in what order they show up. Right? So they'll show up in the way they are in the table. So hopefully that made some sense, right? So you can have a separate provider for all your options. And this way you can control what and how you plot and what order they show up in your chart. All right. Next, I guess tip, or maybe a warning more than a tip. Often we're asked if it's possible to plot, for example, a Boolean as one continuous bar that basically just gets broken and then restarts when there's a value? And the answer is no, not by default. So, or I guess not out of the box. So you can tweak the styling on this type of chart. For example, if you um, change this to area series, right? You can see how, well, right now it's kind of reversed, but you can, again, remember, you can reverse these, right? So you can get it to look like a honeycomb where um, if start is on top, then the filled bars are start, and then empty areas are stop. You can't really get rid of this bottom end of the honeycomb. At least I'm not aware to make to only to spread these labels out to the edges. That's just not what the chart does. So typically, if a requirement is really to have just a bar, a segmented bar, we use SVG Repeater for that. So this is one of those things where SVG Repeater seems to be just it's not easy, but it's easier than trying to tweak a chart to do that. Not just easier, like you cannot tweak chart enough to look exactly like a segmented bar. You'll always have some sort of a common rail, and it will always look kind of like this. It will never look like a truly split segmented bar. So that's just something to maybe to hopefully save you some time, so you don't spend hours trying to get the chart to look like that, where in the end it's not going to. So, that's it. What else do we want to talk about? I guess the important aspect that I should mention is efficiency of plotting things. Now, charts are fairly efficient in terms of resources required. However, there are limits too. So it all comes down to the granularity of data. So in the first example that we've had, not this one here, but the upper chart, I think this is the logic port. So if we take a look at data, um, so remember we brought them to the same cadence, so you have no more than 1 per second granularity, which significantly improved the chart performance because you reduced the number of dots by almost by a factor of 3, right? Where there were about 3 items with the same value for some of them. That means basically the timestamps got, there were 3 sets of 3 or 4 rows. They were very close together timestamp wise. But of course, visually you can distinguish them, but they all get plotted. So that's all resources used by the chart. It's just another coordinate point that needs to draw the line to. So controlling number of data points on a chart is important aspect of keeping them efficient. So make sure you are in control of the date range and the granularity that gets plotted, especially in what order it happens. As an example, if you give user ability to, let's say, plot this year, so the year's worth of data, 1 year or 2 years, and then let's say you either give a user control of the granularity, then of course you always risk a situation where user picks to display a year minutely, right, or even by a second, which could completely overwhelm you by a number of just sheer number of data, size of data that comes in that has to be requested. And then even if that happens, okay, when it tries to plot it on the chart will crash the browser trying to create that many data points. So you have to be smart about it, right? You have to first of all lock out unacceptable options. So if user picks a date range, and you need to check its length and set some thresholds, saying like if the difference between start and end date is greater than this amount, then your minimum interval is this, right? If it's greater than this amount, your minimum interval is this, and so on. It needs to be done basically at the time the data query is constructed, however you're obtaining the data, right? If you use a history block, then this sort of logic needs to play out before the history block is invoked, so that it's not invoked with kind of bad parameters and then the parameter changes, because to make sure they're good, because by that time your request is already out and your server may already start working on this terribly large request. So now you're wasting server resources. So this whatever logic you use to control your date range and granularity when you request the data, well, that needs to take all the possible user limitations and flexibility into account before you make the call, right? Before the call goes out to fetch the data. And of course, when the data comes back, if the data is too granular, let's say your API is just such that you cannot control granularity, once you do have the data, you can basically reduce granularity after that. So if we take this as an example, right, there's a block called rollup. And there's actually two rollups, and there's advanced rollup as well. So let's do that one first. And so you can run the input into this block, right? You can choose the rollup interval. So remember, we have secondly data now. So every second, well, let's say we want to change it to 5 minutes. Tell it which column is our timestamp. We can round it off. We can nest data. So if you don't want to lose these sub intervals, they can be packaged into a table and inserted into this table. So you get table of tables. And of course, you can do multiple values. So because different columns may need to be aggregated differently. So for example, for temperature, right, the average is fine. So input and output will be temp. And then maybe for the next one, which is val1, then maybe you should do max. Right? For example, val1, and you get something like this as an output, and then you'll plot that instead. Right? So let's see, this will have a 5 minute interval instead of 1 second interval. So to the user, secondly data is not critical if you can aggregate it before plotting. And of course, this would go out to the chart to get plotted. The downside of this method, there's not much you can do about this if you plan to use this method, is you have to manually pre-create these columns, which means if you're dealing with dynamic environment where you don't know how many columns you may have, then you cannot use advanced rollup, because it kind of has to mean you have to pre-create all these roll-up columns. But if you don't know which ones you're going to have, you can't pre-create them. So if that's the situation you're stuck with, then you have to do something a bit more advanced. Probably write a script that does that and iterates through columns. Worst case, you can do a repeater basically on each of the columns. So, but you have to use other methods. The regular or rollup block as compared to advanced rollup. And really, advanced rollup kind of trumps the regular rollup in pretty much every aspect. The reason they both exist is for legacy, kind of backwards compatibility. So people who already are using this in their project and update solution builder to the latest, don't end up screwed. But yeah, so regular rollup works the same way, but it's fixed to a single column. Right, so you cannot add multiples like here. That's it. That's it for the rollup. I think we should probably cap this episode at this point.